record. Okay, then the dilemma always is we have two methods, substitution and elimination. What's the glue? Either way, however, in my opinion, substitution is good. Substitution is good when the coefficient in at least one equation is 1 or -1. You see here, coefficient is 1, coefficient here is 1, coefficient here is 1. We have a lot of 1 or -1, doesn't matter. And you take, for example, the easier equation, in my opinion, is the second. And you make a decision to solve one variable that contains coefficient 1 or -1. In this case, there are many ways, not infinity ways, but there are several possibilities to selection. I select, for example, I solve for x, 4 plus y. Now, I substitution this expression in another equation. Where? Here, I suppose. Here, in the x place. You replace x for this expression. Entonces, 4 plus y plus 2y equals 7. We combine later, 4 plus 3y equals 7. 3y is equal to 7 minus 4, que es 3. Therefore, y is 1. And we finish? No, we don't, because I need to find both x and y. So you substitution y equal 1 in either equation, and the equation 1 maybe, and the equation 2. So it doesn't matter what equation you select, the answer is the same. Of course, we are smart, and you select the easier equation. In my opinion, the easier equation is the equation 2 when you isolate x. So x is waiting for me to solve it. 4 plus 1, because y is 1, is 5. Okay, now the solution is the order pair 5, 1. And the alphabetic order, no? X, Y. Super easy. I suppose you remember very well this. Now I want, in any problem that we are solving, try to discussing the interpretation of this. Okay. Okay, look. This is the same problem, no? But the only thing I did was put in decimals, no? To make it a little bit easy, I don't open decimals, directly I create PowerPoint, and, I put inside the whiteboard. Okay, so the important thing is the equation. Well, we have two equations, no? The equation 1, I suppose equation 1, let me use in blue color as the blue line. And the equation 2 is the green color as the green. Entonces, the interpretation in 2D, 2 dimensions. Each equation represents a line in the 2-dimensional plane. And the intersection is the common point, the point in which both equations satisfy, is the solution. So the point 5, 1 is the answer, intersection. See, we have no intersection, we have no solution. See, we have intersection, of course we have solution. See, you have common point, we have solution. Otherwise, no, we have no solution. Clear? Okay. I don't know exactly what happened. Delete. Okay, let's move on to the second example. That was the first one. I suppose that everyone follow it because it's super elementary. I promise I want to complicate a lot of this, but so far no. Suppose this system now, ax minus 2y equal to equation 1. I like to call the number of the equation to refer equation 1, equation 2, equation 3. Remember, when you have several equations, this is more important. Put the name of the equation, no? 4x minus y equal 5. This is equation 2. Entonces I put it here like a curly bracket que indicate that this is one entire mathematical object que is existing, no? And yeah, I need to solve this. Well, now one more time, I can see that in the second equation, the coefficient in front the y is -1. Therefore, I want to take advantage against substitution. Yeah, I solve for y. So I copy again the equation number 2. Yeah, I solve for y. I put 4x minus 5. I move 5 to the left and move y to the right because I want to isolate y alone, no? So this expression 4x minus 5 substitution into the another equation, que is this. Where? Well, you replace for y, no? Here. So we have ax minus 2. I open parenthesis because this y is this entire expression, and these 2 multiply whole thing. So it's 4x minus 5. Should be 5. Should be 5. Now I apply distributive property to remove the parentheses. Ax minus ax again plus 10 equals 5. And you can see suddenly something weird happening in this system. The ax positive and negatives cancel out. So I try to solve the 4x, but I cannot do that. However, you take 10 equals 5, it's completely false statement. Okay, so this is contradiction. See, we have contradiction. Normally in mathematics, when you have contradiction in the formulas, in the solution of the equation, it's because we have no solution. No solution. So this system have no solution. However, in order to make sure that this is the conclusion, no solution, I try to go to the geometric interpretation for the thing. Look, geometric interpretation for the thing. Okay, I put in decimals the original 2 equation. Yeah, I can see that the line, okay, the black line and the red line are parallel. And see, they are parallel, never cross, never touch, never meet. Therefore, we have no common point. That is the reason that we have no solution. This is clear or confusing? Okay, algebraically, you have no idea. You manipulate the equation. Here, super, that means it's clear. Algebraically, you have no idea. So you manipulate. However, when you try to solve it, we cannot. No, it's appear, cancel out. Wow, I have no variable. However, the statement, the final statement is a contradiction. It's totally false. And the interpretation when the situation happens is no solution. Okay? This is clear because it's 2 variables, it's super elementary. However, when you have more variables, this is more confusing. The geometric interpretation is more complicated to say you don't know very well, no? Okay, now example 3. Example 3 is 3x -2. It's equation 1. And we have 6x minus 2y equal -4. Equation 2. Okay, so I take advantage again. Okay, the coefficient in the first equation is -1. Yeah, I apply substitution. When the coefficient is no 1 or -1, so we are using elimination. Okay, don't worry for elimination because we are discussing a lot of problems of the elimination right now. Okay, then, okay, I take my equation number 1, I copy again. I solve for y. I propose you this 3x stay here plus 2 equal y. And now this we take this expression as substitution in the another equation in the y place. So you replace y here for this expression. Then we have 6x minus 2 parentheses 3x plus 2 equal -4. Okay, one more time, you apply this distributive property to remove parentheses. 6x minus 6x. Wow, again something weird happened. And this is -4 equal -4. Okay, this is cancel out. This is say goodbye. And we have -4 equal -4. Okay, this is true statement. Look at the differences between this idea and this idea. It's completely different interpretation. In this case, we have infinity many solutions. Infinity many solutions. Let me try to explain more clear this idea. And what is the interpretation of this? Look. Do you see the equation number 1 here, and the equation number 2 are the same? Because if you multiply the equation number 1, the entire equation number 1 by 2, 2 times 3 is 6, 2 times -1 is -2, and 2 times -2 is -4. So this is one way to verification that the same. Hey, noise. Some people activate the microphone. Please, putting off the microphone. Ow. Bolívar, please. Bolívar.
Yes, sir.
Pulling off the microphone, please. Excellent. Thank you. Now, another way to see the same idea is look. I take the equation 1. Okay, the equation 1 is 3x minus y equal -2, and you manipulate a little bit and solve for y. So I put, well, I did that, no? I did that. It's 3x plus 2 equal y. I did that part. Now the only thing I did is in blue color. No, I did it here in black color. And you take the equation number 2, and we are doing exactly the same. I try to solve for y. So says 6x plus 4 equal to y. When you divide it by 2, we have 3x plus 2 equal y. Wow, look at that. This is exactly the same of this. That proof that this is the same line. That is the reason that we have solution, of course, because they are perfect coincident, 100% of the coincident for the line. Let's see the interpretation. The geometric interpretation is super important, in my opinion. Look at that. When I do in decimals, the equation is expecting, it doesn't matter, okay, you write in that way or in that way. Actually, in decimals, I don't care the way I typing in decimals. I can see the same graph. They are coincidence. So what is the infinity many solution? But this is incomplete solution. This is incomplete answer. We need more information to understand a little bit. Okay, infinity many solution, say all real number. No. Why no? Because this point is no solution. This point is no solution. Only a solution, the point on the line, by the way, is the same line. Entonces, how you indicate this? X, y. Well, solution in this case is, let me write here, solution set is all the order pair x, y such that it's on the line. So you take, for example, you take either equation, okay, by the way, it's the same, no? You isolate one variable, I isolate, for example, y, Entonces I know that y is equal 3x plus 2, comma, and x is completely independent. O sea, x is all real number. This is one way to express the final answer in the infinity-many solution. However, it's not the only way. Another possibility is some book or some book write different, a little bit different. But this is equivalent. Look, you copy x comma, and to say instead of y you put 3x plus 2, and this represents a set of the bunch of ordered pair to satisfy this condition. Okay, so now maybe in intermediate algebra we write like that: infinity-many solution. End the story. No. In college algebra, in more advanced algebra, you need a specification something. Normally, look, one more detail. The terminology of this is sometimes it's called x is free variable. What means free? Free variable. Free variable indicate the variable have no restriction, no? They are not depending on nothing. Why no? Because y depending of x. I declaré x like a free, y I express y as a function of the x. But this is the only way. No. Normally, this is the often thing you can do that like that, but not always, not necessarily. You suppose that x is free and y is dependent. No. You can. Another student say, no, professor, I don't like this. For example, I take this 3x plus 2 equal y. You solve for x. Entonces 3x is equal y minus 2 divided by 3, and x is equal y minus 2 over 3. And we can express the same idea of this in different way. You write y minus 2 over 3 comma y, and you declare in this moment that y is free variable. Okay, so there are many ways using your common sense and your imagination, and well, the rest is easy. Entonces, let me try to summarize the idea so far. Okay, the idea so far is, look, we have three possibilities when solving the system of equation, regardless the dimension. In this case, we are working with the 2D dimension, but in 3 dimension, multiple dimension, we have only three possibilities. We have the first possibility is unique. So we have 2 lines. And the intersecting point is the solution. This is unique solution. Okay, behind this idea, we have one terminology for this. Unique solution, okay, I understand that. However, this is consistent. Okay, the system is consistent. What means to be consistent? Consistent means that we have solution. So we have consistent when you have solution, and inconsistent is when you have no solution. Inconsistent. Like, for example, this example, because they are parallel line, never meet, we have no solution, and the system is inconsistent. Inconsistent means we have no solution. It's equivalent, synonym, no? It's another word. Another word associated with the system is dependent or independent. Okay, dependent. This is totally independent. Independent system. Why is independent? Because we have 2 different graphs for the line. 2 equations represent 2 different graphs. This is also independent. Independent because we have two different lines that represent two different graphs. Different graph, independent. And the same graph, so when the situation happens, when the line is perfect coincidence, so you have two lines, but the red line and the blue line is coincident. You know that we have infinity many solution, infinity many solution. This system is consistent. Remember, the word consistent indicate that we have solution. It's equivalent to say we have solution. The word inconsistent is we have no solution. And it's totally dependent because we have the same graph. And one fantastic way to verification that two equations are dependent or independent was this idea, no? You multiplication by 2, or not necessarily by 2, by any number, by any constant. So in order to verification, if one equation is dependent to another equation, if you will be able to multiplication by number, positive or negative, and you get another exactly equation, so these equations are dependent. And okay, this is the idea is super easy when you have two equations. Maybe when you have three equations, it's no big deal. But when you have 15 equations, it's crazy doing that way. Huh? Okay, do you need to verification by couple? They are dependent or not dependent? No, no, no. Don't worry. The mathematician create fantastic algorithm to solve that problem. Today we discussing the basic idea. The basic idea. Okay, let me anticipate a little bit now for elimination. Elimination, in my opinion, is the best. Elimination. Elimination method is the best. Elimination is super efficiency. And so far, we always using elimination. Elimination method is very, very powerful. And we always, or only, we using the substitution in the case when we have the one variable coefficient 1 or -1. Otherwise, no. But the majority of the case, this situation doesn't happen frequently. 3x minus 4y. This is another example. Example 4, no? Example 4. Equal 1. Equation 1. And 2x plus 3y equal 12. Suppose that this system is given, they need to solve that. Okay, there are many ways to apply elimination. What is the key idea for elimination? Elimination, key idea. Key idea. The key idea is we have exactly the same number, suppose 12, negative 12, and positive 12. I need to do something, manipulation, multiplication. Remember, when you multiply one equation by a number, it's the same. So go. You have this equation, number 1 is a line. Suppose I multiply by 3. This equation multiplication by 3, suppose. The line stays the same, doesn't change. They are depending, and depending doesn't change the geometrical idea. So what is the idea? For example, not necessarily this. If you multiply by 3, okay, this is a symbolic way that we are using, guys. The entire equation 1, and you multiply by 4, the entire equation 2. We have negative 12 and positive 12, at least in the white part. Now it's ready for elimination. Is the only way? No, of course no. Another possibility is you multiply. So I take advantage that this guy is negative and this guy is positive because we need opposite sign. However, another possibility is multiplication by 2, this equation, a multiplication by negative 3, the second equation. Why? Because 2 times 3 is 6x. And negative 3 times 2 is minus 6x. Is another way to do the problem by elimination. But okay, hello. I don't need to solve it for any way. I need to make a decision to say I need to thinking what is the best strategy, no? Entonces you make your own decision. So you are doing well. Your answer is correct, okay? Entonces now you multiply the entire equation 1 by 3, positive 3. Entonces we have 9x minus 12y equal 3. Because 3 times 3 is 9, 3 times 4 is 12, 3 times 1 is 3. And this is my new equation 1, is equivalent 100% to the original. It's the same line, the same line. You put in decimal above, is coincidental line. And when you multiply the second equation by 4, we have ax, because 4 times 2 is a, plus 12y. Oh, nice, exactly. I create intentionally this idea. And your multiplication 4 times 12 is 48. And this is my new equation 2. But it's ready for elimination. So what is the procedure? Well, the procedure is you adding by column equation 1 and equation 2. So you organize in the standard form. The standard form is x first in alphabetical order, y second. In the right hand side, you have only the coefficient. There is 17. The y is cancelled out. This was the intention. And this is 51. And divided by 17 both sides. X is 3. In order to find the y value, you make a decision what equation you substitution. Okay, you replace in any equation. And what? In this one. No, this is too, no, this is not good. Because the number is too big, 9, 12, 49, 48, no. I select the easier equation, okay, it's equivalent. I select, I don't know why, I don't know why. There are no specific reason, but I consider in my mind, okay, number 1 is the easy. And you take 3x minus 4 times 3. Sorry, mistake. 3 times 3, because x is 3, minus 4y equal 1. This is 9. 3 times 3 is 9, minus 4y equal 1. Minus 4y is equal 1 minus 9, que es negative 8, divided by negative 4 both sides, y 2. And the solution is the order pair 3,2. Okay, this is the idea, the basic idea for elimination. Any question? This is, I suppose, guys, the thing we are doing so far is refresh your memory, because you know that. Okay? Okay. Any questions so far? Clear? Confusing? You need some extra explanation? No. Clear. Everything is clear. So I propose you now. Go. Oh, carajo. Here. Go to the word problems. Look at that. Let's do this word problem first. Okay, because I want to see application. I want to see application for the linear system. I understand. I learned that. However, I never see what is the application of this. Okay, so suppose this application easy, no complicated, no. Maybe in the homework I put another example, a little bit more complicated, but no. This is not my intention. My intention, because in the word problem, something is confusing. How you set up the equation, okay? But don't worry, I put easy. For example, typical problem is a mixture problem in which you combine different substance. Okay, in the hospital, using a 15% bleach solution to disinfect a quarantine area. We need 15%. Just this. We need that. 15. Now, how much? So we have two containers. The first one contains a solution at 6%. This is low concentration. Bleach solution must be mixed with the 18. 18 is high concentration in order to get 15. Make sense, right? So you mix it 6% and 18%. That's logical. This is not mathematical like that. It's logical to get 15%. It's the intermediate value in between 6 and 18. It's impossible to get, for example, 25%. This is totally crazy, no? And to get lower than 3% is totally crazy. It's impossible. The one concentration in between 6 and 18 is logical. The thing is how much you need to combine 6% and 18% in order to get 50 liter of the concentration, que es our final goal. So, okay, to make 50 liter of 15% bleach solution. Do you understand the idea? Do you understand the idea? Okay. Step 1, set out the equation. Well, the equation involves 3 quantity. Concentration, C, let me call C, volume, and mass. What means mass? I don't understand what is the mass. Well, the mass, the volume is the total volume. Because when you're talking about 15% concentration, that means that we have in the container, we have a mixture of the water plus a bleach, no? Solution, no? So it's a combination. So you have pure bleach, it's 100%. But if you have 15, no, that means you have 85% of water and 15% of bleach. It's the proportion, no? Because I suppose the whole is the 100. Okay, so the concentration, we have 3 concentrations, 6%, 18%, and 15%. But I forgot to explain what is the mass. The mass is the amount of the pure bleach that we have here. So the volume is, this is exactly the same I need to find. I need to find X and Y. X and Y represent the liters of the first container and the liter for the second container. But I know that the total volume is 50. Therefore, we have the first equation, that is X plus Y equals 50. This is my first equation, equation number 1. And the mass is about pure bleach. And pure bleach, what is the expression that represents pure bleach? Well, in this case, we have 6% of bleach. And the rest, 94%, is water, just water. So the pure bleach is multiplication 0.06x. So I convert concentration from percentage to decimal and multiplication by the volume and indicate me how many liters of the pure bleach we have in this container. The expression is 0.06x. Likewise, 0.18y represent the pure bleach that we have in the second container. However, the bleach that we have here is the multiplication 50 liter multiplication by 0.15. Okay, and this is 7.5. The answer, we'll put in a calculator, 7.5 liter. 7.5 liter is our second equation. Entonces, in that moment, we have 2 equations, elementary equation. The algebra is the easy part. The complicated part is set up the equation. And solving this. In this case, I suppose that the best way for solving this is use of substitution, because I take advantage that the coefficient is 1 here. You take the equation 1, by the way, is the easy equation, Maybe you solve for y or for x, it doesn't matter. In my paper, I solve for y, a 50 minus x. And substitution, this expression here. Here, right? So I have 0.06 tan x plus 0.18 50 minus x equal 7.5. So we have 0.06x plus multiplication, this and this, is 9, minus 0.18x equals 7.5. We combine later, it's negative 0.12x, this and this together. In the right hand side, stay 7.5 minus 9. 0.12x is equal minus 1.5 divided by 0.12 both sides, and negative 0.12 both sides. X is equal 12.5. And this represents volume, no? Remember volume, X is volume. This is liters. So basically, I need to mix the 50 liter that we need. We fix it. We put 12.5 liter of the smaller concentration, que 6%. What about the 18%? I suppose it's bigger, right? But this is pretty easy because I substitution here. Y is equal 50 minus 12.5, and the answer is 37.5 liter. So the confirmation, liters. Okay, this is the solution. Basically, we mix it 12.5 liter of, or add 6% concentration, and 35 add 18% concentration. Okay, that's it. I suppose yes. However, we can, by curiosity, verification that everything is okay. So you take, for example, the most complicated equation, is this, and plug it in curiosity, 0.06 multiplication by 12.5 plus 0.18 multiplication by y, get 37.5, should be, I claim that, 7.5. Y I put in a calculator. Of course, it's true. End the story. I finish this. I illustrate elementary word problem, and solution and verification. The most important is set up the equation. Okay, any question? I am doing too fast. I am doing good. I am doing. Let me know. Come on. Feedback. Let me know. I am doing well. I am doing wrong. Do you understand very well? A little bit confusing. Okay, one more problem. One more problem in 2D. In 2 dimensions. In 2 dimensions. Wow. Okay, one more problem in 2 dimensions. This problem. This is funny. Look. Okay. A river boat traveling upstream. Up means against the current. To travel 24. The return trip, que I suppose que es the same distance, now is downstream. So downstream is in the same direction of the current. And of course, they are going faster because the current helps to move. But the direction of the trip is 2 hours, just 2 hours. Find the speed of the boat in still water and the speed of the current. Okay. It's a classical problem of the motion. So in this case, we have three quantity to understand. First of all, is speed. Okay, I have no idea, but I know, okay, when you go here, you go faster than this, no? We have the distance travel. Okay, by the way, the distance is 24 hours. Look. 24 miles, sorry. Carajo. And the time, que is 2 times, no? Is 3 hours and 2 hours. We have two conditions, upstream and downstream. Okay, basically, I like so much organize the information that's given, the data, in one column. And one column look like a matrices. Okay, we studied in detail last time. It's a super fantastic way to organize a system of equations. Okay, entonces speed, I have no idea. I'm totally lost. However, the distance is 24 miles. 24 miles because it's the same trip in both directions. And the time, no, the time is 3 hours here when you go up again the current, and in the same direction is 2 hours. This is small time. Now I know the speed is the ratio between distance divided by time. Distance divided by time. It's a physics equation, no? Of the motion, the elementary physics. Entonces 24 divided by 3 is 8. 8 what? 8 miles per hour. The speed in that direction, and 24 divided by 2 is 12. Go faster. 12 miles per hour. Okay? Do everyone understand very well this table? Super. Now I'm ready to set out the equation. Because the first equation is about when you go, for example, upstream, this equation is x minus y. So you subtracting x represent the speed of the boat in still water. Entonces en this condition is 8, no? 8 miles per hour. Look, 8. And when the addition both is downstream is 12. Equation 1, equation 2. This is my linear system of equations. Super easy. Now I solve it by elimination. I guess so, right? Elimination is fantastic because when you're adding equation number 1 plus equation number 2, by column, the x column is 2x, the y column cancel out, and this is equal to 20. And divided by 2, x is 10. 10 what? Miles per hour. And this is the speed of the boat in still water. Exactly. And the current, easy. I plug in either equation, maybe in the first one. When the second, it doesn't matter. 10 minus y equal 8. Entonces negative y is equal 8 minus 10. And y is equal minus 2, y is 2 miles per hour. Is the speed of the current of the water. Current water. And makes sense because 10 plus 2 is 12 when you go the same direction, and when you go to opposite direction is 10 minus 2 is 8. Everything matching perfect. We are the best in Miami-Dade College. Any question? Any question? Wow. You mute. Sorry. Jasmine, sorry. This is just the beginning. A lot of no. I suppose que no, because it's 2 dimension. It's super easy. Super easy. No complain for the how many steps. I suppose que it's super easy. Pero you understand or you don't understand? Come on. A ver, let me see. Bolívar. Yalin. Jennifer. Karen. Do you follow me or no? Betancourt. Everyone follow me or no? Sean. Queen, Yamin, Lustin, Lauren, Vance, Yancy, and Frank. No problema, guys. Clear. Okay. Entonces, let's continue. Move on forward. Okay. Now I want to discuss linear system in 3 dimensions. More complicated. In mathematics happen when you increasing the dimension for the problem is more complicated. System of linear equations again. Equation in plural in 3D, 3 dimensions. In general, we have 4 dimensions, 5 dimensions. So the amount of the equation that we have and the amount of the unknown that we have. Basically, the unknown that we have, not the equation, because sometimes not necessarily matching the number of the equation and the number of the variable. We see in detail this. We're discussing now 3 equations and 3 unknown. And the equation and 3 unknown is x, y, z. Okay, x, y, z. X, y, z. Now, in 3 dimensions, and the representation in 3 dimensions, this is x-axis, this is y-axis, and this is z-axis. We have 3 dimensions. You suppose, in order to understand this, you suppose a corner of the one room, no? This is a corner, right? And this is 3-dimensional space. I want to show you now, because we discussing this, or we are doing this using one software, it's Geogebra. Okay? Remember, Desmos is fantastic, but the limitation is only 2 dimensions. But in Geogebra, we have 2 dimensions, but we have 3 dimensions. And you see now with me. But okay, let's discuss first the algebraic part, and after we focus in the geometry part. I bring for you one new example. Example 1 of the 3D is x minus 3y plus 3z equal -4. Equal -4. And this is my first equation. 2x plus 3y equal 15. Equation 2. And 4x minus 3y minus z equal 19. Okay, we have 3 equations, guys. Okay, and 3 unknown, x, y, z. So we are working in the 3-dimensional space. The representation of each equation is completely different to the thing that we're discussing. The representation is the plane. It's the plane. So this is the plane. You see now in Geogebra, it's a plane. So for example, this is one equation. This is a representation, equation 1. Another plane, equation 2. Another plane. You see, in 2D was easy to understand because it's the equation represents a line. It's a 2D. But in 3D, it's more complicated because each equation represents plane. Plane, no line. It's like a 2-dimension object in 3-dimension context. And the line is 1-dimension object in 2-dimension context or environment. Okay, but don't worry. Let's focus here now in the algebra part. Suppose you don't know anything. We have no internet, no computer, no Geogebra. No. Don't worry for this. Let's focus in the algebraic part. The algebraic part just means, are you ready? Because this is too long process. Okay? You, for example, you pair two equations. I pair 1 and 2, but you pair smart, not stupid. Because, for example, I can see using my eyes that equation 1 and equation 2 is ready for elimination in the y part. Yes or no? Because it's minus 3y and plus 3y. So I just copy. The organization is extremely important. The organization is extremely important because it's too long and complicated. I copy again my equation 1. And my equation 2. Yeah, I can see, wow, this is ready. This is ready for elimination y, at least y. And you add in by column. The column of the x is 3x. The column for the y is cancelled. I take advantage of this. The column of the z is 2z. Equal 11. Because 15 minus 4 is 11. Entonces we get the new equation. Okay, this new equation contains only two variables, x and z. Y is go, is removed. And now this equation I call equation number 4. Because this is the new equation that we discover in the middle of the process. Now, this is the most important moment. This is a crucial moment. This is a crucial moment. And this crucial moment, we discover no. We pair another equation, maybe 2 and 3 or 1 and 3. But the most important thing is, if you, in the first step, in the first couple, you eliminate the y, and the second, you must mandatory eliminate the same y. Entonces I take 2 and 3 because I can see que again happens similar situation, 3y and minus 3y. I copy the equation 2 and the equation 3, and you eliminate the same variable que you eliminate in the first combination. I copy equation 1, equation 2, sorry, and equation 3. This is mandatory. This part is mandatory. Okay, you eliminate the same. So you eliminate another, you are doing nothing. Entonces es 6x, the y is cancelled out. Exactly the same happen here. Okay, and this is minus 2z equal 34, no? 14 carry the 134. And this is equation 5. This is my equation 5. Okay, equation 5, good. Now I have in that moment two new equations, 4 and 5. And 4 and 5 is two equations with only two unknown, que is x and c. And we're solving exactly the same we are doing before. Okay, you put together. In this case, by coincidence, and all will happen. So I create this example, super elementary. Okay, in this case, it's ready. C elimination is ready for elimination, and we have 9x equal 45. Divided by 9, x5. At least we have in my hand the x value. I have in my hand the x value. In order to find the rest, que es y and z, use substitution this value of 5 and not in the original equation 1, 2, 3. No. Why no? Because we have 3 unknown and we have in my hand only 1. No. Use substitution and maybe in 4 or in 5. I select in my paper 4 because I consider it's easier. So I try to find always the easy way, not the complicated way. So I take 3. So I copy 3x plus 2z. I copy again, organization, guy, important. 11, I copy equation 4. Yeah, substitution 5 here. 3 times 5, 15, no? Plus 3z equal 11. Entonces 15 plus 3z equal 11. 3z is equal 11 minus 15. 3C, no, 2C. Where come from this 3? Hello. This is 2. This is 2. This is 2. 2, 2, 2. 11 minus 15, que es negative 4. Do Z is equal to negative 4 divided by 2. C is equal negative 2. Okay, almost ready, almost finished, because we have in my hand 2 values. And you plug it in the original equation, maybe in the equation 1 or in the equation 2 or in the equation 3. I don't know why I select the equation 2. I don't remember what the reason I select. But in this case, it doesn't matter. It's 2 times x, que I know que es 5, minus 3y, que I have no idea who is y, minus z, que es negative 2. Be careful with the sign, because this minus is that minus, and this negative 2 is the value for the z, no? So double minus become positive, I suppose. This is 10, this is 2, 15, this is 12. Entonces minus 3y es equal to 15 minus 12, que es 3. Es 3, ¿no? Es 3, es 3, es 3. Wait. Es 15 minus 12. Wait a second. This is plus 2. This is 12. Es 3, pero this is minus. No, this is plus. Sorry. This is, look, I got it wrong. This is plus. Look, I take this equation. This plus is this plus. So 3y is equal to 3. Therefore, divided by 3 both sides. Y is equal 1. And the solution is the triple order x, y, z. And this order, alphabet order, y, z, comma, separated by comma. Entonces, en our example es 5, 1, negative 2. It's the solution. Final answer. Jasmine, too long, eh? Yes. Sorry. Okay. Interpretation this. Okay, I want to use a PowerPoint first. Okay, let me see. I suppose que es this. I suppose this example is this. Let me make a zoom. It's exactly the same. Exactly the same. Look. Let me make a zoom. Let me enlarge a little bit that part. Okay. Okay, this is good. Okay. In this case, I put in the different color. Green is one plane que represent one equation. Red and blue. And this plane intersecting in one specific point, que by the way is this point. I suppose que this point is this point. Okay? It's typical unique solution. But not always happen, no? Remember, in the system of equation, we have 3 possibilities. Unique solution, infinite solution, or no solution. Okay? So now I want to present now. Pay attention. This is the funny part. I like so much that part of the lecture. And we go to the Geogebra. There are different versions of the Geogebra in the market. Geogebra Classic. Okay, so you go to the Google Chrome. I use Google Chrome. It's my browser. You put Geogebra Classic and you open that. I recommend, why not, can you create account? You create account in Geogebra. Exactly the same we are doing in Desmos, can we create account? You remember? Okay, I create account on Geogebra. Let me switch in the share the screen for the Geogebra. Boom. Good, very good. Do you see? Do you see? Excellent. I mean, look, fantastic. Okay, don't worry for this. You only pay attention and you try at home if you want to do that. So this is okay. In Geogebra, when you open, of course, you don't see something like that. You go here to the this selection and you go to the view. In view, I select algebra, que is this window, in which you put the equation and 3-dimension graphic. Okay, we have another possibility, no? Normally, default is not selecting this, that you select. Okay, but don't worry, throughout the course, we learn a little bit because we are using frequently algebra now, okay? Not only for the graphic part. Okay, now, in the example we were doing before, we have, for example, the first equation. Bang! Look at that. It's not playing. You can see, rotate. Okay, this is the plane. You see the second equation. Bang! Blue color. Bang. Entonces, the intersection between two planes is a line, no? And finally, the green color. Bang! Wow. Entonces, the intersection, you can see that we have one common point, that, by the way, is the solution 5, 1, -1. Bagada. Look, let me show you. Let me delete the plane to see the point. This is a solution point. Okay, if you want to restart, press the house here, full screen. Bang, bang, and bang. Is the solution. Super. Do you like? Okay. Let's do it one more. Bueno, okay. Entonces you see that the thing, when you increase the dimension, is very complicated, right? It's very more complicated, at least more complicated. Not very, but more complicated. Yeah. Definitely happen. So when you see you want to study engineer or scientific, and you need to take calculus. Calculus 1 and calculus 2. The graphic 3. Okay. No, but don't worry, because I want to illustrate this idea. Look. Let me show you. This is look like complicated, very complicated. Suppose we have a lot of possibility. Look, I here in the PowerPoint slider here. Look, let me pay attention in this. We have different possibility in 3 dimensions. Look here. Okay. This example, this is very similar to the thing we are doing. We have a common point here, that is the solution. The solution is the common point. And between yellow, red, and green plane. Likewise, look here. It's another example of the unique solution. We are looking the your internet. Okay, let me switch into the whiteboard. Okay, again, do you see whiteboard now? Good. Okay, I think I explain. Okay, for example, in this example, this is very similar to the thing we are doing, que is no solution. One solution, unique solution, because it's a common point between the yellow, green, and red plane. This is unique solution. But however, we have another possibility. Suppose this case. In this case, we have no solution. Well. We have intersection here, this line, and between yellow and red. We have another line here, and we have another line. But we have no common point in between green, red, and yellow. Therefore, no solution. Similar situation happen here, no solution. Similar situation happen here, totally parallel plane, no solution. And this no, this yes, no solution, no solution, no solution. This is unique solution, you need only one solution. However, let's going on. What happened with this guy? Look, this guy. But no red color. Red color no good. Black color. In this case, let me make it zoom to understand much better. In this case, we have a line, a common line, connecting these three planes. So we have infinity, many solutions. And the object que represent the solution set is a line. And the line have one dimension. No? Any line have dimension. No? A plane is two-dimension object. The line is one dimension. So the dimension of the solution set determine the amount of free variable que contain the solution set. 1D represent one free variable. Well, in this case is similar. Look, one line common in between. So we have infinity many solution, one free variable. Free variable. This is not clear. So I understand it's not clear. The concept of the free variable is not clear now. This is also free variable. This is infinity many solution. Free variable. Okay? Okay. You have idea or confusing? Really? When you have intersection, but in between the three equations, the red, the yellow, and the green. When you have, we can discover one common point, we have solution. Otherwise, no. Maybe we have common points in between two equations, but no common with the third one. Entonces, no solution. No solution. Okay, let's move on to another example. And we discuss again algebraically idea. Next example, algebraically idea. Okay, here. Let me move on to this part of the whiteboard. Okay, there you go. Black color. Suppose this example. Example 2, no? This is example 2 of the 3D. It says minus x plus 6y minus 3z equal -8. This is equation number 1. X minus 2y plus 2c equal 3. Equation number 2. This is 3. And equation number 3 is 3x plus 2y plus 4c equal -6. And this is equation 3. And the same strategy, you pair two equations. Okay, I can see, for example, 1 and 2. Wow, good. Because 1 and 2, at least I have negative x and negative x, positive x. So I copy again, negative x. Okay, guys, this is one strategy. Not necessarily doing my way. You select your own strategy. And in this case, I suppose, or I assume que equation 1 and equation 2, this is 3, equation 2. Okay, it's ready for elimination, at least the x part. This is cancel out. This is 4y, 6 minus 2, and this is minus z. Because -3 and +2, and this is equal -5. That is my equation 4. Super, good. Now I take another couple of equations. For example, I take 2 and 3, I don't know why, 2 and 3. Oh, 1 and 3, because the couple 1 and 2 I took 1, 2 and 3, or I copy 2 and 3, okay, I just copy x minus 2y plus 2c equal 3. This is equation 2 again. Look, a repetition again, I copy this. But I take 3, que es 3x, plus 2y, plus 4c, equal -6. This is equation 3. Okay, but you say, wow, fantastic. 2y and -2y is ready for elimination. No, this is mistake. Because remember, we delete, we remove, we get rid of the x. So you must get rid of x and the second couple. This is an important thing. I create this example intentionally to confuse the students, right? Now, so you are adding equation 2 and equation 3. Of course, you delete the y, but you don't do anything, because you take the equation 5 que contain x and z. X and z, I don't like, it's y and z. No. So now I propose you multiplication, for example, the equation 2 by -3. This by -3. Because when you multiply -3 times x and -3x, you copy down, -3x plus, because negative times negative is positive, 6y minus 6c is equal -9. And this is my equation number 2 again, exactly the same, because you know very well when you multiply any equation by a number, it's totally dependent, it's the same. In this case, it's the same plane, because it's a 3-dimension, right? And this could cancel out. This is ay, this is minus 2z equal -15. And this is my equation 5. Okay. So you put together 4 and 5. Okay, look, let me show you. I copy down ay minus 2z equal -15. And this is equation number 5. And we focus in this system of equation. Okay, so I multiplication, for example, multiplication, the equation number 4 by 2, no? By 2 or by -2? Or let me see, by -2, yeah. By -2. If you multiply the equation number 4 by -2, what is my intention? -2 and -1 is +2, and +2 and -2 is ready for elimination. The multiplication, the equation number 4 by -2, thus we have -8. Why? Where I come from? -2 times +4 is -8, and -2 and -1 is +2 is equal, this is -2 and -5 is +10, and this is my new equation 4, no contradiction. Wow, but suddenly weird happened here. This is cancel out. It's supposed that was my, no, and this is cancel out. Wow, this is 0 in the left hand side. In the right hand side we have -5. This is complete false statement. And when this situation happens, immediately you see no solution. No solution. No solution. So you don't know anything. You manipulate, you pair two equations, and you get the equation 4. You get the 5, and you put together 4 and 5. We have exactly the same case of the two equations and 2 unknown. And when you manipulate and you get the contradiction, it's obvious we have no solution. Okay, let me go to understand this, because I need to understand very well. And the geometric interpretation is super important, guys. Super important, the geometric interpretation. Let's go again to the Geogebra. Okay, Geogebra. Okay, let me try to share the screen to Geogebra. There you go. Geogebra. Okay, do you see Geogebra? Sorry. Okay, I have here. Well, okay, don't worry. I go to the here, open, file, open. It's the same manipulation of the folder. This is I click here. Yeah, I see, for example, here. This is infinity many solution or no solution. Let me see, or no solution. I open. Okay, forget about this. Okay, it's exactly again. Okay, this is my rectangular coordinate system. My first equation is this. Do you see Geogebra, guy? Do you see or no? Yes or no? Yes. Okay, good. Okay, you see Geogebra. Okay, the first equation, I don't know why I put the first equation always red color. The second equation, you can change the color if you want. You click here, look, this is fantastic, guy. You click here and you setting. In setting, you make a decision, the color and the transparency in this handle. I don't know, you practice, after you practice by yourself. Okay, this is my first equation. My second equation, we have intersection, why not? And between the plane, good. Okay, and by the way, let me see it's this line. Yeah, the intersection is this line, can put in black color. And the third plane is this, green color. So I don't see very well if we have common point or no. I do the line of this. Oh, and you see the line, look at that, the line, this is the line. The line are parallel. So the intersection between two planes is a line. The intersection between another two planes is a line. And these lines are parallel. It's exactly the same, the conclusion we get algebraically. You combine two planes, two equations. Equation number 4 approximately represent the first line. And you pair another two planes, and you get the 5 equation that represent the other line. But I discovered that the lines are parallel. That is a reason that we have no solution. No solution. No solution. No solution. No solution. No solution. Guy, you follow me? You understand? Are you boring? Amazing, yes. Okay. Let me try one example of the infinity many solution in 3D. Let me try one example of the infinity many solution in 3D. Suppose this is example 3, no? Of the 3D. Okay, I want to erase the board. Well, yeah, I want, because I need the space. Erase everything, guy. Okay. Suppose this. I erase even the PowerPoint. Suppose 2x. This is example 3, no? 2x plus y equal -3. This is equation 1. Sometimes happen that one variable is missing in the one equation. It is possible. The second equation is 2y plus 16c equal -10. And this is equation 2. And the third equation is -7x minus 3y plus 4c equal 8. Equation 3. Okay, this is the system. It's a little bit crazy because in the first equation z is missing, and the second equation x is missing, and the third equation no. Everything is okay. Okay, don't worry. For example, I pair, or I match, or p-pair equation 1 and equation 2. I copy 2x plus y equal minus 3. This is my equation 1. And you copy here 2y, I put it here down, x is missing. Some people prefer put the 0x, but I don't like this. And the matrix, yes, when you will study the organization, because we are solving, this is the classical way for solving the system. But we have another fantastic way using the matrix. I repeat again this idea. Okay? 2y plus 16z equal negative 10. This is equation number 2, no? Okay. Now, in order to eliminate, for example, the y, I make a decision to, the strategy I planning was do multiplication, the equation 1 by negative 2. Because I know that when you multiply negative 2, it's negative 4, and negative 2y equal 6 positive. Okay. Ready. 1 plus 2. Okay, this is 1 again after the multiplication. I bring down minus 4x, the y cancel. That was intention. C, we have this. Just bring down plus 16z equal negative 4. We are coming from negative 4, negative 10, and positive 6. And this is my equation 4. I can simplification. Of course I can. Because I see that the number is divisible by 4. So you divide the entire equation number 4 by 4. We have by 4 or by negative 4. Well, by 4. By 4 first. By 4, and by 4. Because I want to reduce a little bit in lowest term. This is minus x plus 4z equal negative 1. No? Another student said, no, but professor, I divide by negative 4. Because it's too much negative. So it's x minus 4z equal 1. Nice. This is my equation 4. Okay, let me enclose in the box because it's important. Okay, now I go to the second part of the game. The second part of the game, I pair maybe 2 and 3 or 3 and 1. But in my paper I do 2 and 3. I copy 2y plus 16c equal minus 10, que is equation 2. I copy again. I copy 3 now, que is minus 7x minus 3y plus 4z equal 8. Is equation 3. Okay. And remember, it's very, very important. See, I delete y here in the first couple. I must delete y here in the second couple. So I propose this strategy. You multiplication the entire equation 2 by 3, positive 3. Here I multiply the entire equation 3 by positive 2. What is my goal? Well, my goal is 3 times 2 is 6y, and 2 times negative 3 is negative 6y. Let's do it. The multiplication, the entire equation 2 by 3. So it's 6y plus 48z equal negative 30. This is my equation 2, new. I multiply the equation 3 by 2. It's negative 14 x minus 6y plus az equal 16. And this is my equation 3. Ready. I bring down negative 14x. This is cancel out. This is 56 Z, and this is minus 14. And this is equation 5, no? The equation 5. Just I can say, wow, look at that. I can divide by 14, everything by 14, by 14. By 14 or by negative 14, I suppose. By negative 14, by negative 14, by negative 14, because I like so much. You know, reduce in lowest term. So we have x, positive and negative, 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 negative. This is negative 4, because 16 divided by 14 is 4z equal 1. And this is my equation 5. Wow, something weird happened. The equation 4 and equation 5 are identical. They are twin brothers. That indicate us that we have infinity many solutions. Okay? This is a similar situation that happened in 2D. In 2D, for example, you get the identity, I don't know, 0 equals 0. It's infinity many solution. And this is equal this is equal that. Entonces, okay. Entonces, what should I do? Well, I suppose that we have one free variable, because maybe the intersection is a line or is a plane, I don't know. I declare z like a free variable. Entonces the only thing I should do is express it, the other variable, x and y, as a function of c, que c is the free. Well, actually, I have the equation 4 and the equation 5 que say que x is equal 1 minus 4c. Okay, entonces the only thing I need is maybe express a y as a function of z. Well, actually, I have here in the equation 2, we have 2y plus 16z equal minus 10. So for y is equal to 2y is equal minus 10 minus 16z divided by 2, whole thing. Y is equal minus 5 minus 8z. So y as a function of z is negative 5. Negative 5 minus 8z. Okay. Entonces one way to express it, the solution set, que by the way, I know que es infinity many solution, and the clue que give me information que es infinity many solution is because this expression and this expression is identical, is, I suppose que the triple order x, y, z, such that satisfy this equation and this equation, so x is equal 1 minus 4c, comma, y is equal minus 5 minus 8c, comma, and c is all real. Okay, by the way, it's identical to say free variable. This is one way. Another possibility is not necessarily this curly bracket, no. You open one parenthesis, entonces you declare que x is 1 minus 4c, comma, y is negative 5 minus 8z, and c is just c. Indicate it's free. It's two different possibilities to express the final answer, que es infinity many solution. I suppose that in this case, we have three equations, and one plane is like that, another plane is like that, and the intersection is a line, and another plane intersecting in the same line. That is a reason that this solution set, the geometric interpretation is a line in 3D. In 3-dimensional space, we have a line que es 1 dimension. How do you know que 1 dimension? Because we have only one free variable. And what is the free variable? Z. Si you have two free variables, entonces es a plane. Pero okay. Let me try. Let me try to see in Geogebra now. Okay, any question, guys? Do you understand this is a little bit confusing. I understand that. Okay, okay. Let me summarize. You don't know anything at the beginning. You pair two equations and get equation 4, and you pair another two equations. Not necessarily 2 and 3. You pair another, but you eliminate y again, because in the first step I eliminate y. In the second step you eliminate the same y. And suddenly, wow, we have twin brother equation. 4 and 5 is the same. This is a clue que give me clear information that we are in front and the system que contain infinity many solution. No unique solution. Now, in this moment, we declare one free variable. Okay, I declare z. But you can declare x or y, it doesn't matter. And you try to express it algebraically, find x and y as a function of the free variable z. And you express it in any way, like a order pair or like this notation, no? Que es set builder notation. Anyway, let me see the geometry interpretation specific in this example in Geogebra. Guys, you don't need to do graph in 3 dimensions. This is calculus 3. Okay, by the way, I am teaching in the summer. No, it's one picture. Okay, my opinion is useful to understand the idea, right? Okay, let's move on to Geogebra. Okay, Geogebra now. Okay, that was the example in the first one, the last example. Okay, no line. Suppose this example. Wait a second. Do you see Geogebra now or no? Do you see or no? Guy, answer me. Yes, okay. This is this example. This is the first plane. It's interesting when one variable is missing. And the first equation is 2x plus y equal negative 3. So z is missing. Maybe I forgot to say que the red axis is the x, the green axis is the y, and the blue axis is the z. So when this plane z is missing, is because this plane is parallel to the z-axis. In this case, this plane is parallel to the x-axis. Look. Bang. And this no, it's oblique. However, the curve, que es the intersection, is one line, common line, que connecting 3 planes. That is the reason que we have infinity many solution. And what is the infinity many solution? Infinity many solution is the point on this line, que es common in between red plane, green plane, and blue plane. And you see that they are perfect coincidence in between the expression 1 plus 4z minus 5 minus 8z, and I declare z like a free variable. It's a one possibility, but not the unique possibility. Do you see or no? Confusing or clear? Okay, one more example. Let me see if we have time. Yeah, we have time. One more example. Very, very interesting example. Okay, I want to erase everything in the board. Let me come back to the whiteboard. Okay. Whiteboard. Okay, do you see whiteboard? Look at this stupid example. Look. Suppose, what number is example 1, example 2, example 3, example 4 of the 3 dimension. Is x plus y plus z equal 10. This is equation 1. The second equation is 2x plus 2y plus 2z equal 20. And the last equation is negative 5x minus 5y minus 5z equal negative 50. This is my system. It's given in the test. And you solving that. And you can see, wow. You see equation 1, equation 2, and equation 3 is the same. Because if you multiply the equation 1 by 2, you get the equation 2. And if you multiply the equation 1 by negative 5, you get the equation 3. So what is the representation? The representation is in 3 dimensions. I suppose que it's a plane, no? It's a plane. It's a plane for the equation 1. But it's the same plane for the equation 2. Here is the same plane for the equation 3. Remember, the geometric representation for the equation, depending of the this equation are dependent. It's the same object in 3D. So we have solution or no? What do you think? We have solution or no? I need to hear opinion. See, we discover that we have in front one problem that represents the same plane repeat 3 times. One plane, 2 plane, 3 plane. It's the same. We have solution or no? All solution, infinity many solution. Very, very well. Infinity many solution. But this problem is a little bit different to this problem. Look. Okay, we are doing before. Remember the before we have a plane. We have another plane here. And we have another plane here. And the solution is a line. The line can represent one dimension object. Therefore, that means we have one free variable. But in this case, no. In this case, the same. So say any point on the plane. And by the way, this object represents one object in 2D because it's a plane in the 3-dimension environment or context. The environment is the same in both. But here, one-dimension object que corresponde algebraically one free variable. And here is 2-dimension, entonces I suppose que corresponde with the 2 free variable. Because it's the only possibility to represent one 2-dimension object in 3-dimension context. Okay, entonces you declare 2 free variables. Suppose que x and y are free. And you express it x like a function. Entonces x is equal, for example, you take the first equation, and by the way, it's the same, 2 and 3, is 10 minus y minus z. And y and z are free variables. How you represent that? Well, okay, solution set. It's easy. It's all triple order such that x is equal to 10 minus y minus z, comma, z and y both are free, are all real number. And this is a representation for the plane. Okay, this is one way, that is one possibility. Another possibility, okay, some book prefer you put the other pair and you put in the first component, que es x, you put 10 minus y minus z. And in the second component you put just y, and the third component you put z. This is equivalent to this. Entonces I suppose, assume que y and z are free variables. Do you understand very well? Well, let me see in Geogebra to understand this. Let me see to complete the picture. Big picture. Let me see in Geogebra. Okay, switching to Geogebra. Boom. 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 I got it. Okay, that was the previous example. Now in the new example, we have a plane. 3 equations. 1, 2, 3, 1. Blue, red, and green. You see it's the same? Overlap the plane. Therefore, the plane, to represent the plane algebraically, we need 2 free variables. Crystal clear or confusing? Confusion or clear? Clear. Okay, nice. Nice. I like that. Okay, let's move on to the whiteboard. Okay, in the whiteboard, I want to pretend now to solving one word problem. Okay, let me try to find PowerPoint. Okay, PowerPoint, please. Okay, there you go. On this PowerPoint, I want to, okay, select this slide. Bang. Okay, let me try to understand the word problem. Okay, it's about Janet. Janet invested a total of the $18,000. This is the total money that she has. But she split the money in 3 accounts. No account, it's investment. In 3 different mutual funds. She invested in the bond. So the name is bond fund. Okay, fund. That return 4%. So this percentage is associated with the first. Okay, the first amount of money is X. This is money. 3 money. I split the money in However, she invests in another case called aggressive growth fund, but she lost money because normally but sometimes happens in the aggressive, you earn a lot of money, but you lost money also. And the other case, no aggressive, you never lost, but you increasing a little bit money. And Z is the another account. The name is International Fund, return 2%. Okay. However, Janet invested 2,000 more in the growth fund than the other 2 funds combined. Okay. This sentence give me information for the one equation. And if she had a net loss, she lost money, $540 for years. How much did she invest in each fund? Okay. Let me set out the equation. So the complicated part always in the word problem is set out the equation. Okay, let's do it. It's obvious that the first equation is x plus y plus z is equal 18,000. Okay, this equation. This money I split in x and y and z. I don't know, not necessarily the same. Not necessarily split divided by 3. No. This is crazy. Let's focus now in this sentence. This is Janet invested 2,000 more with the ground fund than the another 2 combining. So the ground I call like a y. So y alone is equal, minus combining is x plus z. So x represents 4%, z represents 2%, y represents negative 8% because and the subtraction both quantities represent 2,000. This represents my second equation. Don't expect that when you set out the equation is totally nice, perfectly organized. No, no, no. I set out exactly like the word problem say. I translate from English to mathematical equation. And now, the third equation is about the total return. Entonces, the first return was positive 4%, is 0.04 multiplication by x. This represents the money for that way. The money for that way. Okay, by the way, is positive. The second, no. The second is negative. It's negative 0.08 y. You lost money here. Oh, Janet, no, me. Another, Janet. Plus 0.02 multiplication by z equal, I suppose that in total, you lost money is negative 540. And this is equation 3. Okay, so we start the problem now. After you understand very well the situation for the application for the word problem, you set out the equation, okay, in my opinion, is the most complicated part. And we start the problem. Okay, so now I need to start the algebra. I need to do something in order to put in a standard. So I put the x like that, x, y, and z in the same column, no? The column for the x, the column for the y, the column for the z. In the right hand side we have the number, no? This is my equation 1, gets perfect organized. But the second, no, the second is crazy. Well, no, it's not crazy. It's minus x plus y minus z equal 2000. Equation 2. And the third yes is very, very crazy. I highly recommend eliminate the fraction. The fraction or the decimal, sorry. And multiplication by 100, everything. When you multiplication by 100, well, we have 4x minus ay plus 2z equal 540 multiplication is negative 54. How many 0? 1, 2, 3, no? 1, 2, 3, 0. 1, 2, 3. This is the third question. Okay, more clear now. Okay, we are ready. We are ready to apply algebra now. So I make a decision. Okay, you spend some seconds to planning the best strategy. In my opinion, is you pair equation 1 and equation 2. Minus x plus y minus z equal 2000. Equation 1, equation 2. I'm ready for elimination because I can see negative x, negative y. Oh, wow, amazing. C and x cancel out. Good. 2y is equal 20,000. Divided by 2, 10,000. 10,000 was the money que Janet invest in the aggressive mutual fund que have 8%. And what about the rest? Well, the rest plugging in, but plugging in where? Plugging in, for example, in the equation 3. Either equation, you select either equation. I plugging in. No, in the easier equation. What is the easier equation? The easier equation. When I plugging in, and because I have only one, I plugging in the third equation. Plugging in the third equation here. Okay, it's 4x minus 8 multiplied by y, que es 80,000, plus 2c equal negative 54,000. Okay, now I copy just like that. 4x plus 2c is equal minus 54,000 plus 80,000. Entonces 4x plus 2z equal 26,000. Yeah, I call this equation 4. This is my equation 4, que contain two variables. So I plug in this number here. In the first equation is x plus 10,000, because remember y is 10,000, plus z equal 18,000. Entonces x plus z is equal 8,000, because 18 minus 10 is 8,000. And this is my equation 5. And you put 4 and 5 together. 4 and 5 together. I want to copy now. 5 stay here. 4x plus 2z equal 26,000. Equation 4. Entonces, in my paper, by multiplication, the easier equation is this. By negative 2. By negative 2, you multiply this. Entonces, minus 2x minus 2z is equal minus 16,000. This is my new equation 5. It's equivalent, no? And you have 2x. This is cancel out. And this by 2, x is equal 5,000. In order to find the c value, it's super easy, because, for example, I take this equation, either equation, but you always try to find the easy. So 5,000 plus z equal 8,000. Therefore, z is equal 3,000. When confronting 3,000 is 8,000 minus the distribution of the money que Janet are doing at the beginning. No? Any question, guy? Super easy or super hard? Are you feel good or you scared with this chapter? And this is just the beginning. This is just the beginning. I expect next week more complicated thing, right? Okay, super. We finish for today. Too much. Okay, say goodbye. Bye.